In this module, we are going to explain what a system call, how it differs to system program and its functions and services. We are the three presenters for this day, Felix, Carlo, and Aldrin from BSIT 2A. So, what is a system call? A system call is a pragmatic way in which a computer program requests a service from the kernel of operating system it is executed on. A way for programs to interact with the operating system, where computer programs make a system call when it makes requests to the operating system's kernel. This provides services of the operating system to the user programs by Application Program Interface or API, and an interface between a process and operating system to allow users level processes to request services of an OS. System calls are the only entry points into the kernel system that generally written in C or C++, although some are written in assembly for optimal performance. All programs needing resources must use system calls. Now I'm going to show you different system calls. The purpose of some of it to better understand it perfectly. First is the open system call. This is used to provide access to a file in a file system. It allocates resources to the file and provides a handle that process uses to refer to the file. A file can be opened by multiple processes at the same time or be restricted to one process. Second is the read system call. This is used to access data from a file that is stored in the file system. The file to read can be identified by its file descriptor, and it should be opened using open before it can be read. In general, the read system calls takes three arguments, and these are the file descriptor, the buffer which stores read data, and the number of bytes to be read from the file. Third is the write system call. This writes the data from a user buffer into a device such a file. This system call is one of the ways to output data from a program. In general, the write system calls takes three arguments, and these are the file descriptor, the pointer to the buffer where the data is stored, and the number of bytes to write from the buffer. And lastly is the close system call. This is used to terminate access to a file system, using the means that the file is no longer required by the program, and so the buffers are flushed. The file metadata is updated and the file resources are deallocated. Here is an example of how system calls are used. Writing a simple program to read data from one file and copy them to another file. Program inputs. Program opens the input file and create output file and open it. Each of these operations require another system calls. Now that both files are set up, enter into the loop that read from input file and writes into the output file.
So, what is its difference with system program? As said earlier by Felix, a system call provides an interface to the services made available by an operating system with two modes of how programs can be executed. Namely, the user mode in which a process with no access to the memory, hardware, and the like resources. The other one was called the kernel mode, where in this, there is an access to the memory, hardware, and the like resources, or in other words, it was called the privilege mode. The programmatic way in which a computer program requests a services from the kernel of the operating system, generally available as routines written in C++ or C++, and these are not directly executable by a high-level language program such as C, Fortran, or Pascal that enables a programmer to write programs that are more or less independent of a particular type of computer. System programs, on the other hand, are those important aspects of a modern system, commonly used to program the operating system software. This provides a convenient environment for program development and execution. And some of them are simply like a user interface to system calls. For the differences of each, within the program, system utilities such as system call are used. These are calls made by an application or processor for the specific execution of a block of code, also known as computer interruption. Call the CPU to run the program with higher priority and later run other commands. A C routine that interacts with operating system functionality and can be compiled into a system program, specifically provides an interface between the calling process and the operating system. While the system programs are those executable files. These are the programs required to use and operate the system, machines, input, output devices, and other connected peripherals that were also known as system software.
Under this topic, this is also related to how the functions and services work provided by the operating system, which can be divided into two categories. The first category of functions makes the operating system useful and helpful to the user. The services provided in this category are the following. User interface. In this, the users can send commands to the system. It may be a command line interface, a GUI, or a batch ordering system. These are usually older systems that use punch cards from the Job Control Language or JCL, but can still be used today for a special purpose system. Program execution. The operating system must be able to load a program into memory, run the program, and terminate the program normally or abnormally. I/O or input-output operations. The operating system is responsible for transferring data to and from input-output devices, including keyboards, terminals, printers, and storage devices. File system manipulation. In addition to storing raw data, the OS is also responsible for maintaining directory and subdirectory structures, mapping file names to specific storage units, and providing tools to navigate and use the file system. Communications. Having an inter-process communication or IPC between processes running on a single processor or between processes running on a separate processor or separate machines can be implemented as shared memory or messaging, or some systems can provide both. And error detection. Both hardware and software errors must be properly detected and handled with minimal harmful consequences. Some systems may include complete failure, prevention, or recovery systems, including backups, RAID disk, and other redundant systems. Debugging and diagnostic tools help users and administrators find the root cause of problems. The second category of functions exists to ensure the efficient operation of the system itself. Thanks to these function systems with multiple users that can gain efficiency by sharing the computer resources among their users. The functions which are part of this category are resource allocation, CPU cycles, RAM, disk space, and peripherals. These are some resources managed by the shared systems, while others are managed by carefully designed and customized systems that are customized for a specific resource and operating environment. Counting. For billing purposes or to keep track of statistics, consider system activity and resource usage, which can be used to improve future performance. Protection and security. Prevent damage to systems and resources through unexpected internal processes or malicious outsiders. Authentication, ownership, and restricted access are obvious parts of this system.
Highly secure systems can carry all process activities down to the smallest detail, and security rules stipulate that these records should be stored in secure, external facilities on a long-lasting, non-erasable medium. To describe these briefly, there are different ways to define different categories of an operating system, services, and functions. In general, an operating system provides an environment for the execution of programs. So in this case, the difference is made on the efficiency and usefulness of the operating system. One category of services makes the operating system helpful to the user, while the other one is helpful to the system, such as providing the input-output operations, services, file system manipulation, communications, and error detection. While the second category contains and gives resource allocation, counting, and protection. The difference between the two categories is made based on the use and efficiency of each category.